Good morning to all. Today we are discussing about internal block diagram of operational amplifier. The internal block diagram of operational amplifier I show in figure. Okay, in this the first block is the differential amplifier. This differential amplifier output is given to the intermediate stage. Okay, so here in this intermediate stage also we are using the differential amplifier. Okay, and this intermediate stage output is given to the level shifter, and this level shifter output is given to the voltage follower, and this voltage follower output is given to the load. Okay, and sometimes these stages we are considered as this is the first stage. Okay, and the intermediate stage we are considered the second stage, and the level shifter stage we are considered as the third stage, and this voltage follower stage we are considered as the fourth stage. Okay, and now we are individually discuss about each and every stage. Okay, in this first one is the first stage. Okay, the first stage we are also considered as the input stage. Okay, the input stage of the operational amplifier consists of dual input balance output differential amplifier. Okay, and now first of all our doubt is what is the differential amplifier. Okay, and we know that this is the amplifier. This amplifier we are giving the weak signal, and it will providing the strong signal. Okay, and here we are considered the dual input balanced output differential amplifier means here the circuit can accept the two input signal. Okay, with the difference of these two input signal, it will providing the output. That circuit we are considered as differential amplifier. It means that the differential amplifier is required the two input signal. Okay, and these two input signals are not same signal. Okay, and the mathematical relationship between input and output of the differential amplifier is V0 equal to A into V1 minus V2. Okay, so here the A we are considered as the gain of the differential amplifier. Okay, and here we are giving them both the inputs are the different signal. It means that, for example, here we are considered this signal, and the inverted version of the above signal we are giving to input of the this second signal. For example, we are giving the same signal, then the output equal to what? 0. Okay, therefore this amplifier is not amplify the this input. Okay, and here we are remember the one important point is the differential amplifier accept the difference of the two input signal. Okay, that signal is amplified it and providing the output. Okay, so in this operational amplifier internal block diagram we are using this differential amplifier. Okay, and now here we are drawing the circuit diagram of the differential amplifier. Okay, this differential amplifier consists of the pair of the BJT. Okay, so here we are connecting the BJT, and here we are considered the another BJT. Here we are connecting the external power supply VCC, and here we are giving the two input signals. Okay, this is the circuit diagram of the differential amplifier. Okay, and we know that the differential amplifier is required the two input signal. Okay, these two inputs we are considered as a dual input. Okay, and we are collect at the output at each and every BJT character terminal. That is we are considered as the balanced output. Okay, so that is the reason in this first stage we are using the dual input balanced output differential amplifier. Okay, and for example, we are collected at the output only at one collector terminal of the BJT, that is we are considered as dual input unbalanced output differential amplifier. Okay, so this circuit we are using at the first stage of the operational amplifier. Okay, and now our doubt is in this first stage why we are using the differential amplifier, why not using the this single stage amplifier. Okay, for example, in this single stage amplifier, this input signal is given to input of this amplifier, and the amplified version we can collect at the output side. Okay, and for example, this input signal is affected by the noise signal. Okay, this is the noise signal. Then this amplifier amplify this input signal and also amplify the noise signal. Therefore, the affected noise is adding to this output signal. Okay, and for example, in this differential amplifier, okay, this input signal V1 is affected by the noise signal. Okay, therefore V1 equal to V1 dash plus Vn means some noise signal, means the noise signal is added to this input signal. Okay, and similarly the same noise signal is affected to this V2 signal. Okay, that is V2 equal to V2 dash plus Vn. Okay, and these two signals are given to input of the differential amplifier. Okay, then we can calculate the output is V0 equal to A into V1 equal to what? V1 dash plus Vn, and V2 equal to minus V2 dash minus Vn. Therefore, this noise signal is cancelled. Then we can getting V0 equal to A into V1 dash minus V2 dash. It means that this differential amplifier eliminate this noise signal. Therefore, the amplified version signal is presented at the output side. Okay, that is the reason in this first stage of the operational amplifier we are using the differential amplifier. Okay, next we discuss about second stage. Okay, we know that this second stage we are also called as intermediate stage. Okay, in this stage the output of first stage is connected at the input of the second stage. It means that in this op amp block diagram, this is we are consider the first stage. Okay, this first stage output is connected to input of the second stage. Okay, and the next point, second stage of op amp is dual input unbalanced output differential amplifier. It means that in this block we are using the dual input unbalanced differential amplifier. It means that this is the circuit diagram of the dual input unbalanced output differential amplifier. It means that we are connect the output at both the collector terminals of the BJT, that is we are called as balanced output. But in this circuit we are collect the output at only one collector terminal of the BJT. So this is we are considered as the dual input unbalanced output. Okay, this differential amplifier is used at the second stage. Okay, and third point, this stage is used to further increase the voltage gain to get single output from the dual input. It means that in this first stage also we are using the differential amplifier. Okay, but this differential amplifier is not producing our required gain. Okay, therefore this output is given to again input of the another differential amplifier. Okay, so this second stage differential amplifier should providing our required voltage gain. That is the reason in this first stage and second stage we are using the differential amplifier. Okay, and one more point in the second stage is there is a direct coupling between input stage and the second stage, due to which the DC level of signal at output of second stage is well above the ground level. It means that when we are cascading this first stage differential amplifier and the second stage differential amplifier, we are not using the coupling capacitors. Okay, and these coupling capacitors can blocks the DC. Okay, if we are not using this coupling capacitor, the input signal DC level can be improved. It means that, for example, here we are considering the input signal. Okay, and after amplifying the signal, here adding some DC. Okay, this DC is 1 and here we can getting like this. Okay, and again this signal is given to input of the second stage differential amplifier. Okay, so again this second stage differential amplifier can adding another DC level, then the signal strength is improved. Okay, so we want to achieve this output signal at the output of the second stage. Okay, so here we will not using the any coupling capacitor. Okay, and next we discuss about third stage. Okay, this third stage we are considered as a level shifter. Okay, this stage of operational amplifier consists of an emitter follower or level shifter. This stage used to bring DC level of signal to ground level. It means that in this block diagram of the operational amplifier, this is we are considered the first stage, and this first stage output is given to the second stage, and this second stage output is given to the third stage. Okay, so here the third stage is the level shifter. Okay, this level shifter we are considered as a clamper circuit. We know that this clamper circuit can be act as a DC restorer. It means that it will remove the DC signal. Okay, but here our doubt is why we are using the level shifter. What is the functionality of this level shifter? Okay, and we know that here we are giving the very weak signal is the input. Okay, after performing the differential amplifier operation, here we will get the output is some DC level is added, then this is the output signal, and then here the DC level is 1 volt. Okay, and this output is given to input of the second stage. Okay, and again this differential amplifier add some DC voltage, then here we can get the output is this is the 2 volts DC, and the signal is amplified like this. Okay, but now here we need to remove this DC level, and again here we are get this signal is the ground level output signal. Clear? But here our doubt is why we are removing this DC level. Okay, for example, if you are not using this third stage, this second stage output is directly given to the fourth stage. We know that the fourth stage is the voltage follower, so maybe there also we are using the BJT. Okay, for example, this BJT can be operated in the active region with respect to the cut-in voltage VBG equal to 0.7 volt some value. Okay, for example, if directly this output signal is given to input of this amplifier, then the operating point of this BJT can be changes, therefore this can be moved to in the saturation region, therefore the signal is not amplified it. Clear? Therefore we need to avoiding these problems. Okay, in this third stage we are using the clamper circuit. Okay, this clamper circuit can be act as a DC restorer. Okay, this clamper circuit can remove this DC signal to again this signal come back to the ground level. Okay, and next we discuss the fourth stage. Okay, the fourth stage we are considered as a voltage follower, or we are considered the power amplifier. Okay, so here the role of the power amplifier circuit in the fourth stage is we know the functionalities of the first stage and second stage and third stage. Okay, so here we can getting only one output, and this is the third stage, and here we can get the amplified signal, and this signal is given to input of the fourth stage. Okay, and here we can connect in the load. Okay, but here our doubt is what is the role of the this voltage follower circuit or the power amplifier circuit. Okay, here one important point is this overall circuits have the high output impedance. Okay, so directly this output is given to the load. Okay, this load is not transmit the signal properly because this load have the minimum impedance. Okay, so here we are using the power amplifiers. Okay, but here the power amplifiers cannot amplify the signal. This power amplifiers transfer the maximum power from the input side to the output side. Okay, so in this fourth stage we are using the power amplifier for transferring the maximum power of signal from the input side to the output side. Okay, and this power amplifier have the high input impedance and low output impedance. Okay, so here occurring the matching impedance, and this power amplifiers can satisfy the maximum power transfer theorem. Okay, and what is the maximum power transfer theorem? In this maximum power transfer theorem, we want to transmit in the maximum power from the source to the load. Definitely we can satisfy the condition is what? The load resistance equal to source resistance, means definitely here the matching impedance is important. Clear? So we need to satisfy this maximum power transfer theorem condition. Definitely in this fourth stage we are using the power amplifier for transferring the maximum power from the input side to the output side. Okay, so finally this output we are connected to the loudspeaker. With respect to the in this whole operation, the maximum output signal we can get it at the output of the operational amplifier. Okay, so with respect to these four stages, we are amplify the signal in the operational amplifier. Okay, thank you.